Morning, everybody. I'm posting this for all my classes, so I hope you are all watching. For Math 2, here is your current grade sheet. This is what we're doing today, is reviewing area. But just so you know, the plan that I sent to the sub, it says you should complete assignments as I'm posting them on Google Classroom. I'll be posting 114 today, 115 tomorrow, 116, 117, 118 for the rest of the week. And I'm not exactly sure what they are, but you'll see them be posted, and likely there will not be a video to go with it that I'm making. I'm going to show you on Khan Academy what I want you to be watching. AP Calculus, here's your grade sheet, and you know that Xander's going over some stuff on optimization. I could be off on the day. Don't worry about that. I am giving you guys a review of all of these formulas, which I'd like to do like literally right now. So for the shapes that you'll be using for your optimization problems. Anyway, for Math 2 and 2 plus, area of a semicircle, we have let me go back to Khan Academy. So here we are on Khan Academy, and I am in your unit, solid geometry. I'm in the Math 2 section. In the solid geometry section, if I click into there, it looks like this, and this little piece right here, cross sections, I want to do those tomorrow. In order for you to be ready for those, I'm going into this assignment right here, getting ready for solid geometry. So here it is, and I'm going over it with you now. So why do we need? We want to figure out area is the amount of space that's enclosed in a 2D figure. And then if we know the area of that, we can consider it a cross section to a 3D figure. So that's where we're going. And by the way, I intend to complete this whole section for Math 2+. Now for Calc, kids, I just wanted you to see this article, and notice down here it says you can go to this practice area of a circle, area of a triangle. I do want you to do those, so I actually did assign them. And for Math 2, I also assigned these. So how do you do these problems? Well, first of all, before I leave the actual article, I wanted to mention to you that if you click up here in this corner, there's 2 problems, and I'd like you to do both, okay? And if I scroll down here, then you click in here, there are actually 4 problems, and I'd like you to do all of them. And then again, down here, these are the practices that I'm giving you guys. I didn't look at this one. I'll look at it tomorrow and decide if I wanted to assign it or not, but I think I got enough for today. So now I've saved all of those questions into my OneNote, and here they are, and I plan to use this reference sheet. And I know you guys want me to have it printed out, and I'll see what I could do for you tomorrow, but I just couldn't get it organized today. And so don't, pause. Just actually do the work. This paper comes from the SAT. It's the SAT reference guide. And so when you guys take the SAT, every single one of these formulas will be on that paper for you, and you'll see it, including these sentences, which are very nice. All right. So I'm just going to use this, and you can look it up on Google anytime you want it. So I don't think we really need to print it out. All right, so here we go. What is the area of the following semicircle? Well, I was just looking at it. So the area of a circle is pi r squared. And notice how I put a little circle down there? That just helps me remember what shape it is that I'm trying to find the area of. And we've done this previously. This one we've actually did last semester, so hopefully you'll remember it. And also, when you remember that, I prefer to just use pi. I don't like to actually pull out the calculator, but you do you. I don't care if you want to. And notice if you do use the calculator that it's 3.14, not 3.14159, the way I have a bunch more digits memorized. No, they just want 3.14. So that's why I don't like it. Anyway, the SAT wants it to be 3.141, and that's why I dislike that. But anyway, moving forward, I'm just going to use pi. So if the diameter is 10, that means all of this is 10. I actually just want to do this, and this is my radius, and that would be 5. So the area of the whole circle would be pi times what? 5 squared. The only problem is that I only have 1/2 of a circle, so I'm going to throw 1/2 out in front. And 5 squared is 25, and you divide that by 2, it looks like this. And so I typed in 25 divided by 2 pi, and I got a little check mark, okay? Now, the area of a triangle is always tricky for you guys. The area of a triangle is 1/2 the base times the height. But if you don't have a right triangle, then how do you know what the height is? Okay, so if it's a right triangle that looks like this, then this could be the base and this is the height. But we don't have a right triangle, so we don't know what the base and the height is unless we look at the picture very carefully. So I'm looking at this picture very carefully. I'm saying I want that to be the base. I know it's been flipped upside down, but I want that to be a base because why? Because this is a right angle. Now they've marked it right here, which is kind of a weird place to mark it, but that is what they mean. And so that means this is the base and this is my height. And so if I'm doing 1/2 the base times the height, the area should be 1/2 times 10 times 25. And I'll just do this piece first because 1/2 of 10 is 5. And 5 times 25, oh my darlings, I hope you remember, 5 times 25 is going to be 125. It's the same thing as 5 times 5 squared, which is the same thing as 5 cubed, which you should know is 125. Okay, so I would put in 125 right there. So I have not done this. We did cover this topic, but I just use a worksheet. I didn't know the Khan Academy was, I didn't think about it. It's out there and it's really brilliant. So I want you guys to do it. I did assign this. Then I'm moving on here to a cylinder, and I hope that you know things about a cylinder, which is that the base is a circle. And so I need to find the area of a circle, and then I'm going to multiply it by the height of the cylinder. So the area of a cylinder is basically the area of a circle times the height. So the formula works out to be the area of a cylinder works out to be, ready, 2, nope, sorry, my bad, pi r squared times h. And let me double check that formula by going over here. Do they have a cylinder? There it is, pi times r squared h. All right, so then what does this formula tell me then? That 6 is my radius, so I have pi and I have 6 squared times that height is a 4. And so I'm saying that I want you to throw that into the calculator and get your answer. 36 times 4. I did it earlier. I feel like it's 36 times 4. I think it's 120, that's 144. Yeah, so 144 pi. Okay, and when I clicked the button, I checked it. I got it right. I actually haven't done these yet, so I will probably plug them in. The video is getting long, so I'm going to try and shorten it up. Okay, so then the volume of a cone is a little bit different, and there's a video that you can watch here on the Khan Academy that goes through why the volume is what it is, but I just use the formula V equals 1/3 pi r squared times h. I guess a cone is 1/3 of a cylinder. So a right cone, there's a right angle here. It's not slanted. If it was slanted, then it would look like that, right? That's not slanted. No, we don't have a slanted. We have a right cone. So then my radius is going to be 2 and my height is going to be 9. And there's a pi here and there's a 1/3 here. And by the way, 1/3 of 9 is the same thing as 3. And there's a pi still times that 2. And so I'm saying that I need to multiply those together and I'm going to get 6 pi. So 6 pi. Then I'm moving on to the next one, the volume of a sphere. Oh, I love the volume of a sphere. It's so exciting. Okay, 4/3 pi r cubed. And I love it because we use it in calculus, volumes of revolution. If you take an actual circle, equation of a circle, and then you rotate it, you get the volume of a sphere. It's so awesome. I'm not sure if I assigned that Khan Academy video for you. Maybe if you pop me an email, I'll show you that video for calculus students. Anyway, this is my radius. So volume of a sphere is 4/3 pi r cubed, and I want to say then that the volume will be 4/3 pi and 8 is cubed. And go ahead and put that into a Desmos in the following way. You know how I like to have my pi be there? Well, the reason for that is because then I have less things to type into Desmos. So all I'm going to type into Desmos, ready, is the 4/3, and then the 8 being cubed. And ooh, well, you know what? I don't even want to do that now. I don't even want to do that. I want to leave my answer exact. So 4 times 8 times, 2048. 2048 thirds pi is what I'm going to do. Notice how I just typed in the numerators because I wanted my answer to stay exact. So I found out what that number was on Desmos and I left it divided by 3. Let's go over here and see if that worked out. So I'm on the article and I'm doing this, not that one, not this one. I'm doing this one, not that one. I'm doing this one, not that one. I'm doing this one, and I said 2048. 2048 divided by 3 and a pi. And let's see if that's right. It seems really big. Yay, I win. So there you go. And then the last one says Olympic-sized pool at the recreation center is a right rectangular prism. Okay, rectangular prisms are basically just cubes. I mean, well, like a box, right? There's my box. And it says it's a right rectangular prism that's 50 meters long and 25 meters wide. And the pool contains 3,000 meters cubed of water. Well, volume is supposed to be the length times the width times the height. So if they told me the volume is 3,000 and that, one of these numbers is 50 and one of these numbers is 25, I'm supposed to be able to solve 25, please. 25, please. I'm supposed to be able to solve, ready, by dividing by 50 and 25 on both sides. 50 and 25 on both sides. And I'm going back to Desmos. Where's Desmos? And I'm going to say it was 3,000 divided by, and notice how I'm in the denominator here, and all my numbers are going to stay in the denominator. 50. Nope, that's not in the right place. I want it over here at the 50 and the 25. Boom. 2.4 is 2.4 meters deep. Seems reasonable. 2.4 meters deep. So a meter is 3 feet. And so if I had 2 meters, I would have 6 feet. A depth of 6 feet is pretty good. But if I had like almost half of a meter, 1/2 of a meter would be another a 1.5. So we're talking about a 7.5 deep pool. Yeah, 7.5 feet's not very deep. I like a 10-foot deep pool. That's my favorite. That's the one you could have a diving board on. 7.5 feet, not so much. But anyway, there you go. That is your guys' video, and I miss you all, and I'm doing fine. And I am planning on one Zoom before my surgery. I'll let you know what the date is. You'll see, and you'll be able to plan to bring your device to school and be in the Zoom.